Hey everyone, welcome to the fourth video of Module 8, and here we are going to create some basic visualizations. The first one is to look into the output categories that we are having in the dataset, and then the second thing is to get the distribution of these astronomical objects in sky. We're going to use the right ascension declination along with the redshift to plot the data of stars, quasars, and the galaxies. So let's get started. And now we can go ahead and create these visualizations. And for that, I'll be requiring the matplotlib library and specifically pyplot module of it. And therefore, I'll import matplotlib.pyplot as plt. And I'll run this code. And the first thing that I'm going to plot over here is to check the count of galaxy, star, and quasar in our data. Well, we have already seen this in format of a pandas output, that is with the help of value counts. But if I want to comparatively study it with the help of visualization, how can I do it with the help of pandas directly? So for that, what I'll do is I'll again do df of the class and then value counts, because we know this is the way through which we'll be getting the unique counts of each and every class that is present in this column. And on top of this, I'm going to do dot plot, and over here I'll be giving the argument as kind and call it as bar plot. And after this, if I want to have a customization as in the colors, if I want to give, I can use this color and create a list of it. And the colors that I'm going to look into is dark blue, then a normal blue, and then maybe let's say a royal blue. And with this, if I just go ahead and look into what are the different kind of things given over here. So the customization of the plot is given over here in the format of the X sticks. We are changing the weights of the X sticks to bold and changing the rotation equal to 0. And the title, we are having everything we are having. The only thing that we are not having is the way through which we can display the values of each and every counts on top of the bar. And that's the reason why am I using this AX is equal to this. It is because of this AX, that is the axis, we will be able to do this step. So for that, I'll be using AX dot bar underscore label, and inside this again I'll use AX dot containers, and on the 0th position we have this values of the counts, and that's what I need to pass in over here. Okay, after this you can have any kind of customization on top of this. Let's say for example color is equal to maroon, and if you want to have weight is equal to bold, then you can go for that as well. Everything else, I guess, does not really need any kind of explanation. That is straightforward. That is the X text and the title that we are giving with some customization. And we are also saving the figure, calling it as class distribution.png, and then finally visualizing it. So if I run this code, hopefully it runs fine without an error. And there we go. We are having the output. If I can scroll it down, there we go. And yeah, the output that we are having is pretty much neat. And just in case if I really want to show you what we have done over here by using rotation is equal to 0, let's see what happens if I move this rotation command and then run the code. You can see that the output of the X sticks are now 90-degree rotated. And therefore, this is something that I don't want in my output. If you are comfortable with this, you can have it in your output, but I am not comfortable with this. And therefore, I'll be using the rotation is equal to 0. And yeah, whatever saves your board, you can just use the method that you like it. But this is the output that I would like to have as the part of the output that you can see over here. That is what we have saved with the help of savefig command. Now you can download this into your system and use it for your, let's say, report, thesis, whatever kind of work you are doing. All right. But I'll just close this up. And these numbers that you are seeing over here on top of all of these bars are actually responsible because of this line. It is because of this bar label and the containers we are able to fetch that how many amount of galaxy, star, and quasar are present, exactly how many, right? And clearly we can notice this difference that quasi-stellar objects or the quasars are very much less in quantity as compared to galaxy and star. So this is a highly imbalanced data, right? Now to solve this imbalance in our data is going to be much more advanced as compared to what I had planned for this project. So we're not really going to solve this imbalance in the data. Rather, we are going to look into what is the kind of output that we are able to achieve, even if we keep this imbalance in the dataset. And now what I want to do is I just want to visualize that how my stars, quasars, and galaxies are distributed in the given dataset. So for that, I'll be requiring two things, that is right ascension and the declination coordinates. through which I'll be able to map all of the stars, quasars, and galaxy. And on the z-axis, I can use redshift and look into how it is going to look overall. So for that, if I want only the data of the stars, okay, if I just want the data of the stars, I can simply go into the data frame, and then I can say that wherever the class is equal to, let me just check what was the, it is capital STAR. So wherever the class is going to be star, I want all of those rows given to the star df. Just like this, if I copy this and paste it over here, and let's say that this is for QSO. And similarly over here, the final thing that we'll have over here would be for the galaxy. Make sure that you're giving the same name that are present in the data frame itself, all right? And then I'll just bring all of them to one level, and that's how it's going to look like. So if I run this code and just give you one example of how this is going to look like, so star df. So if I show you the class of this, every class is just going to be a star. I can show you the unique value with the help of value counts, and you will see that there is only one unique value, that is star. I guess I just need to give class over here that I forgot, but there is only one class, and all the data with respect to that will be the output. You see some silly errors I'm doing over here. I'll just come take it up, now run it. So yeah, you can see that there is only one output for the stars, and similarly I can also have it for the galaxies. And similarly for the quasar, you will see that all of them are having its respective classes itself, nothing more than that. So everything looks good. And now we can simply use this data in order to get this plot for the stars, galaxies, and quasars mapped all together in just one output. For this, what I'll be needing over here is that I'll be creating a subplot with only one axis and use the projection as 3D. After this, all of the code over here is pretty much self-explanatory, given that if you are aware about the very basics of how we can go ahead and do this kind of plotting. Still, I'll just go step by step. We are first of all having the figure with the figure size of 15,15. Then I'm having only one axis that I'm plotting with the projection is equal to 3D. After this, I'm going to add a scatter plot, one from the star data frame, one from the galaxy data frame, and one from the quasar data frame. And on the z-axis, I'll be having the redshift. On the x and y, I'll be having red ascension and the declination coordinates. So for that, I'll be using ax.scatter. Then from the star df, I'll get the right ascension. After that, I'll get the declination, and then I'll have the redshift. After this, I can give a label to this as, because we are using a legend over here, so I'll just give a label to it as star data, something like this. After this, I'll just copy this and paste it and simply change the star df to galaxy df. I can even do it in a better way with the help of a for loop, and I can loop through the star df, galaxy df, and the quasar df, and even that would work. But for now, I'll just galaxy df and galaxy df. And the last thing that is left is the quasar df. So QSO df, and finally QSO df. Let's see if we are missing out on anything. We are having the X label as right ascension, Y label as the declination. We are giving the pink colors, setting the weight of the text as bold. Similarly for the Z label. And the title for this axis would be object distribution from the STSS. That's absolutely correct. And over here, I'll just give the name over here as the objects for the star, galaxy, and the quasar, or I can also call this as celestial objects. And after that, we are just going to save the figure. And if I run the code, So this is the output that we have got. So if I just zoom out, that's how it's going to look like. And it's coming in the proper way. Celestial objects, star data. Okay, it's every time it's using just the star data. Oh yeah, because I just use the star data, I need to change this to galaxy data and this to quasar or QSO data. Yeah, now it's looking good. And even if I look into this folder, why is this graph dancing? I'm not sure. All right, so over here we are having the class distribution output as well. Okay, not that, the object distribution from the SDSS, that's the one that we're looking into. So yes, if you just take it up a bit like this, that's how it's going to look like. Now let's try to have some of the observations before we move any further. So the observations that we can make over here is that the orange and the blue data, okay, the orange and the blue data, it is simply belonging to the star and the galaxy data. Green ones are the quasars. So we can see that the distribution of the stars and the galaxies are pretty much very similar, and therefore our model might find some of the difficulties in order to have this kind of distinction between galaxies and the stars. At the same time, if I talk about the quasars were very much less in amount as compared to the stars and galaxy, but we can clearly see some kind of a separation between galaxy and the stars as compared to quasars. And therefore, that's what I believe, that quasars won't be having a lot of difficult times, even though its overall class was having very less values as compared to the stars and the galaxies. That's our assumption. Let's just go ahead and see if this kind of assumption holds true. All right, I'll just zoom in. And yes, the same observations are written over here. So that's about the visualization part. So yeah, that's it about this particular video over here, guys. And now that we have understood the data set, now it's time to go ahead and create this kind of a train test plate. And that's what we'll be doing in the next video. So stay tuned for that.